Hey everybody, this is Quasar and I am here today to talk to you about carbon. So carbon is an element on the periodic table. It has 6 electrons, four of which are in its outer or valence shell. So it has 4 bonding sites available to it. We know it in the form of coal. We also know it in the form of diamonds, which is just coal under a lot of time and pressure. And we probably have also heard a lot about carbon dioxide. So carbon is really important to life, and we exhale that carbon in the form of carbon dioxide. We also emit CH4 or methane. So let me just show you both of those real quick. Carbon dioxide. What is that molecule? What does that even look like? I like how smokestacks first. Well, it's 1 carbon bonded to 2 oxygens through this double bond. And if I search methane, so carbon monoxide is just 1 carbon and 1 oxygen. Mon, right? Di, 2. And CH4, methane, is 1 carbon bonded to 4 hydrogens, right? Because it's got those 4 bonding sites, single bonds. All right. What? Anyway, so the story of carbon on Earth is really complex and super, super interesting. And you may have seen it in this simplified version form of the carbon cycle. You know, we learn about the water cycle, precipitation, whatever. And this is a similar kind of thing. It's carbon. It's the atom of carbon, a physical thing, and how it moves through Earth's living and non-living systems, or biotic and abiotic systems. So usually we think about, I like to start with the atmosphere just because it's an easy place. You can start anywhere, right? But I'm just going to start with the atmosphere. And it's found as carbon dioxide or methane or carbon monoxide. Plants are able to take carbon dioxide and through the process of photosynthesis, they lock it into sugars and other forms of carbon like lignin in their systems. And animals will eat that. And they will in turn release carbon dioxide back into the atmosphere as they breathe or through methane, as they do other things like fart. Carbon can be directly absorbed into the oceans and into other bodies of water like rivers and streams. It can be eroded through the weathering of rocks like limestone, right? Calcium carbonate. And it can be emitted through the process of burning fossil fuels like coal and natural gases. So it's a really simplified version of the carbon cycle. Here's another one that sort of gives a little bit more detail about what these things are and other ways that carbon is emitted and moved through the system. So another big part of photosynthesis is the phytoplankton in the ocean. Actually, algae produce, it gets a little confusing because we're not talking about oxygen, but they produce more oxygen than land plants. So think about algae as doing more photosynthesis. I think, actually, that might be a lie. I'm not going to say that because I actually don't know, but they do a ton of photosynthesis and lock carbon dioxide into the ocean's food web, which actually oftentimes will end up having those sediments buried in the deep ocean, and then eventually they can be upwelled through ocean currents or taken in by organisms and brought up to the surface again, or they will go through the very, very, very long process of the rock cycle and eventually come back up through weathering and erosion, or be made into coal and gas and then burned and then brought back up again into the atmosphere. So carbon is cycled in food webs, in these land and ocean food webs, and then also can be found in these like longer geologic processes like the rock cycle, or these really fast events like erupting volcanoes, or like a burning forest fire releases carbon as well. And there's also tons of microbes going on, and they are doing their thing as well, and they respire carbon dioxide too. I also like this diagram because it identifies in purple the reservoirs, or we also sometimes call those sinks for carbon, like where it's stored, and then processes. So diffusion, just straight up from the ocean surface, because there's like oxygen, it just goes both ways into the ocean and out of the ocean. respiration, photosynthesis. Anyway, so I thought that was a cool version. So people often will talk about the greenhouse effect, right? So carbon dioxide plays a huge role in the greenhouse effect. It's not the only gas that plays a role. Methane, as a carbon gas, is actually is more effective as a greenhouse gas. And water vapor, H2O, is also a powerful greenhouse gas. And we actually wouldn't exist here on Earth if it weren't for the greenhouse effect. Those gases in the atmosphere help to trap heat in the Earth's environment, which is important to life here. However, the more greenhouse gases there are, the more heat is trapped. And so that's what we are experiencing when we talk about climate change and the overall warming effect that it has on the Earth. So we've got incoming solar radiation in the form of visible light, right? And then some of that infrared light does radiate out into space, but our atmosphere, those gases reflect it, some of it back down onto Earth as well. So Venus has a really effective greenhouse effect, and it's really, really, really hot on the surface of Venus. Mars, not so much. Actually, if we wanted to terraform Mars, we would need to probably instigate, whatever. We'd need to have a greenhouse effect, and maybe we could make that happen somehow if we were terraforming it. Okay, and we also know that through data that has been collected since the early 50s from the Mauna Loa Observatory, and also like all over the world, but this is like the classic station where it was first reported that there was this rising trend in carbon dioxide. And we've been seeing this trend happen since the 1800s and the Industrial Revolution, right? So pretty steady, Industrial Revolution, and we got this big CO2 increase. And with that, and we measure that in parts per million, carbon dioxide in the parts per million. So 1 carbon dioxide in a million parts. That was a bad explanation. Anyway, is of it rising. And this little up, down, up, down, up, down, up, down is because of the yearly cycles that we have for seasons, right? So plants are absorbing less carbon dioxide in the winter when their leaves fall than in the summer. So we see that dip happen in the summer of carbon dioxide. Cool. So there's other ways to visualize carbon's movement through the Earth. And this is a really cool diagram of carbon fluxes, and it actually measures the amount of carbon in these different reservoirs, right? So the soil has a lot of carbon in it, 1,580 gigatons of carbon. And it does release some of that into the atmosphere through respiration and diffusion, and then also it brings more into the soil than it releases through microbes and through direct absorption and things like that. And so I thought this was a really cool mathematical way to visualize where carbon is in our system. And we do talk about kind of two forms of carbon. We talk about like fossil carbons, which are really old and are bound up and would have stayed bound up in like something like coal or oil for a really long time. And so when we release that fossil carbon, it's sort of like additional than what would normally be there. And then we have like our living systems carbon, which is what would normally be cycling through our ecosystems. So we're really not concerned about that carbon. We're concerned about the additional fossil carbons that we're adding into that cycle. Okay, so there is a ton more I can talk about with carbon and the carbon cycle, but hopefully that gave you just a little bit of foundation and grounding to be able to think about your own carbon diagram. And I actually, when I did a search for them, I'm not happy with any of the carbon cycles out there on the internet. So hopefully you guys will make one that is both simple and detailed enough to be useful, that involves processes as well as like reservoirs and maybe even some numbers involved and some mathematical representations. Okay, hopefully that was a little bit inspiring. Go forth.